Ladies and gentlemen, welcome back to the inaugural Science for Life Symposium. This is panel session number 2, The Future of AI. This panel discussion will now commence. We would like to extend our warm welcome to the Minister of Information and Communication, who will be joining us online today. We'd like to welcome our chair, as well as our distinguished scientist speakers and our VIP guests. As well as, of course, all of the AI experts who are also present here in this room and here in Vietnam, offline and online for this session. A warm welcome to everybody. Ladies and gentlemen, artificial intelligence is on all headlines lately, acting as the main driver of emerging technologies like big data, robotic, and the Internet of Things. AI is believed to be a technological innovator for the foreseeable future. Now, the intelligence designed by humans and demonstrated by machines seems to have tremendous impacts on how we do things and relate to others. The question is, will AI ultimately help society and individuals move forward to achieve equality, fairness, humanity? Will it fuel competitive advantage or make leapfrog innovations? All will be discussed in the session today. Now, to start this panel going, we'd like to invite you, the audience, to have a look at the screen for a short clip, and I'll be right back.
AI is probably the most important thing humanity has ever worked on. I think of it as something more profound than electricity or fire.
Google, Facebook, Apple, Microsoft are all moving ahead at a great speed in improving this artificial intelligence software. So it's very exciting, making us more efficient.
Since its emergence, AI projects are continuously moving forward. Global AI market investment continues to grow at a staggering rate. AI is present and serving humanity's best interests. AI is believed to potentially help humanity solve some of their most complex global problems. However, with its self-learning ability, will artificial intelligence challenge our existence?
AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
Human history is an ongoing conversation. And AI could very well be an opportunity for humankind to close the gap, be more equal, and have a better quality of life.
Well, ladies and gentlemen, that was our clip for panel number 2. I'd now like to invite the chair for panel number 2, The Future of AI, Dr. Padmanabhan Anandan. Dr. Anandan, welcome to the stage. I'd also like to invite our other scientist panelists for this panel. Offline joining us, we have Dr. Bùi Hải Hưng. Dr. Bùi Hải Hưng, welcome on stage. We also have Professor Vũ Hà Văn. Professor, welcome on stage. And we also have Professor Albert Pisano. Professor Pisano, welcome on stage. To our panelists that are offline, your mic is right where your couch is, and it's already turned on, so you do not need to turn it on anymore. And we also have 2 panelists joining us online. First is Professor Jennifer Tour-Chase joining us online, as well as Dr. Shredong David Huang. Both of them will be joining us online. So I'd like to commence panel discussion number 2, and Dr. Anandan, the stage is yours.
Yeah, thank you, and thank you for organizing this panel, and thank you all for joining. Obviously, a very exciting and important topic. Everybody knows something about AI. I'm not sure any of us know everything about it. So what we were thinking is that divide this conversation into a few key topics, and we'll go through them sequentially and have conversation amongst the panelists. The first thing, of course, naturally is what is the state of progress in AI? How much is real? How much is hype? The second one is how do we ensure that AI actually works well? How do we guarantee, certify, make sure that it's reliable? The third topic is a topic that we broached upon a little yesterday, which is how do we make AI beneficial to everyone in the society, not only the haves, but the have-nots as well. And of course, an important question that comes up in thinking about AI is ethical aspects. Is AI going to do things fair, or is it going to be biased? Is it going to be doing things that are in a transparent manner that we can understand and control it? And we are scientists, and we've heard, in this forum, besides AI scientists, we have medical scientists, material scientists, and physicists. So how has AI helped or can help other disciplines of science progress? And of course, given we are in Vietnam and there's exciting growth and development, and we have WinAI and WinBrain, what's the prospects for AI in Vietnam, and how should Vietnam approach AI? And of course, the last question always comes up, which is speculatively, what is the future of AI? What's the good, what's the bad, and so on. So let me begin the conversation with the first theme, which is about an assessment of the state of AI. How is AI doing? How much is real? How much is hype? Let me invite Dr. Zudong Huang to start comments on that, and the other panelists can respond, of course.
Thank you, Anandan. It's great to be here with all of you. So it's amazing. We are able to really participate from the US. So on the state of AI, I really want to just talk about the amazing revolution from the deep learning. In the past 5 years, deep learning really changed almost everything on how we do AI. And people actually start to use large model with massive amount of data, and whether it's OpenAI's GPT-3 or Google's G-Shot, they will reach like 600 billion parameters. Still smaller than our human brain, but the trend is getting bigger and bigger. So the resulting foundation models really give us this unprecedented experience, whether it's speech recognition, machine translation, language processing, decision, or anything you can think of, is actually now close to be possible. But fundamentally, the current deep learning-based approach, they are having two limitations. One is really like the GPT-3 OpenAI model or G-Shot. They are really focused on learning from one modality. As a result, just can you imagine, you can lock yourself in a dark house, just read the newspaper. You can actually just, you can learn the language. So as humans, we learn from observing the reality, interacting with people and read. So that is actually how people learn. So we feel that the journey in optimization to explore the intersection of different modality is one of the unexplored area. Even though they are research, but they really focus on audio, visual, and the language all together across different languages is probably going to be super exciting. That's almost like a metaverse, what we can experience, because you can really have different senses. The second area is really how we can combine the last generation AI, like expert system, the rule-based approach, into the deep learning, basically the symbolic AI and the deep learning AI, we feel that they are really possibility. And the latest, like Microsoft reached the human parity on common sense Q&A, is try to combine those two approaches all together. So given the progress, I think that on the perceptive AI is going to actually be super useful, whether it's speech recognition or computer vision. On the cognitive side, this will be even harder. Between those two is like machine translation. You can really translate up to 150 languages with high quality. People might think, oh, you really understand the language, but we pretend. The AI actually today pretends to understand. It's based on deep learning, sequence to sequence mapping. So that is really the high-level summary of the current state of AI services. The bigger companies like Google, Amazon, Apple, Microsoft, they all offer AI as a solution, like 3 cloud service providers, Azure, cognitive services, Google, GCP, and Amazon, they all offer the pre-built API. So if you want to just consume some of those AI services, they are broadly available across the world. So that's really what I want to summarize at this point.
Thank you.
Okay?
Yeah, thank you, XD.
Anandan?
Thank you, XD.
Thank you.
Now, I'm going to ask some of the panelists, Hung, for example, any other major areas of applications of AI where you're seeing already benefits and where you think it's going to be growth?
So I think XD's answer was really excellent. I mean, he really gone really deep into how the technology has developed really fast over the last 5 to 10 years, and the main technology behind it, which is deep learning, and the fact that AI models is getting larger and larger. If I need to add, then perhaps I also want to add the fact that in many applications, you actually need to have these AI models not running in the cloud, but actually, on the embedded device. And an example of that is autonomous driving or robotics. And we've also seen, tremendous progress also over the last 5 to 10 years. That now you've seen that the cars, even though that they're not at a level that it can actually drive by itself, but we actually have access to systems that can actually assist the driver and make the driving task by the driver a lot safer and a lot more comfortable. And you also seen examples of AI running on devices, in systems that you can interact with at home, systems like personal assistant, system like help you to control just about the devices that you have in your house and so on. So it's really AI has really gone to, it is actually taken by granted for people that we have access to all of this technology today without actually thinking that it's actually AI. So I think that's great.
Thank you, Hung. Jennifer, I know you had some thoughts about AI applications in medicine, but maybe you can also extend it to talk about the limits of current AI, where there is too much hype and people may be believing things that are beyond what we can really do.
There are wonderful applications that we're starting to have in medicine. Right now, when someone has a disease, it's very hard to the data is actually somewhat sparse. And yet we can use AI on images and things like that to have a better idea of what is the best intervention in something like cancer, where you don't have a lot of chances at different interventions. You want the right intervention first. But some of the limitations, I think that there are cases in which people believe that AI is on the verge of overtaking human beings. People talk about artificial general intelligence, AGI, And I and most other experts do not feel that we are nearly there yet. Artificial general intelligence really would require that we know how to coordinate all of these different multimodal streams that XD was talking about. And we are really not nearly there. So I think there's a great deal of hype about artificial general intelligence. These wonderful, 600 billion parameter models still can't do things that a baby can do.
Thanks, Jennifer. XD, you briefly alluded to the idea that maybe AI is just pretending to understand when it comes to language. Can you elaborate on that a bit?
So the AI really pretends to understand. That is the concern. If you really ask the hard question, unlike humans, they can reason, they can really explain what it is and have a conversation or dialogue. That's where AI fails. So I just want to really highlight, deep learning is a nonlinear mapping function from one sequence to another sequence. It has this extraordinary memory. When you have used, like a trillion or 2 trillion parameters, like Microsoft Turing with NVIDIA, you can memorize a huge amount of information. But that's it. So whether it's a speech recognition, like a map from speech wave into a sequence of words, or computer vision, face recognition, you memorize your face with the identity of the person, or translation, that is to map from one language to another. It does amazing, amazing work, better than humans. Microsoft in the last 5 years, every year on the research benchmark, will clear one research breakthrough, reaching human parity, whether it's speech recognition or image captioning or translation, whatever, right? But that is a well-defined limited task, a well-defined research task. When you put the AI in the wild, like what Jennifer said, you need a context, you need awareness, you need a multimodality, because we use all the senses to make a decision, to communicate. That's what AI is absolutely behind. So I just want to put this in a context. AI is a fantastic nonlinear mapping function, but for knowledge acquisition, like, you still need to go back to the AIs in the 70s. We don't have a good solution.
Thank you. Thank you, XD. Yeah.
The cognitive part is the challenging part. That's why we are still far away from AGI, as Jennifer said.
Thank you. Now, there has been a lot of... Professor Wu, yeah.
Hello? Yeah, so I try to, there's something about the limitation of AI, and from my point of view, it probably partially comes from the fact that we don't really understand why deep learning is working, right? So it works wonderfully for many things, and then it doesn't work for many others. And then mathematically, we don't really understand this model. So there's no theory behind it that proving that deep learning is working for this and for that, and why it doesn't work for other stuff. Say for instance, for this 600 billion network, probably it may use only maybe a quarter of it, but we don't know. I mean, it just worked for 600 billion, but we never know that maybe we can shrink the deep network down a little bit. And that part, I think we are far from understanding the whole theory of deep learning and explain. And then that's why it's very hard now to predict that how we can proceed in the future.
So is this a case where the technology is actually getting ahead of the science?
Yeah, exactly. So I usually compare it with like the process of making nuclear bomb, right? So for nuclear bomb, we actually understand the science very well, the theory of physics, and then we make the bomb. Now we just have the equipment, but we don't really know how it works, or why it works, actually.
Well, whether we like it or not, it's getting applied, it's getting used, and people think it works. But how do we ensure that it works right, and it's doing things in a way that we can believe and control? Al, I know you had some thoughts on this.
Yes, I did, Anandan. in discussions the group had in preparation for this meeting, I introduced the concept of AI fiduciary. Everyone wants AI to be ethical. That means on the average, it doesn't harm anyone. But taking an analogy to financial investment, a fiduciary is someone who is certified and bonded to be working on your behalf, not the behalf of an institution. So as we see more AI applications come about, I think it's going to be very important to see a concept of an AI fiduciary, a set of AI algorithms that are in essence certified and bonded to be working on the behalf of the user, not the larger system that's implementing the AI. Now, I'm not saying you want to put all interests of all individuals ahead of all groups. That's not what I'm saying. I'm saying right now, you don't see that balance because there is no fiduciary on the other side. So I think when we see these sorts of mechanisms incorporated, I think a lot of the issues of who's benefiting will be worked out because we will know that there is a balance.
Yeah, that's actually a natural segue into AI ethics. So let's switch orders a bit. Jennifer, I know you have been thinking a lot about how to ensure that AI behaves in an ethical manner and that it's responsible. Can you share some thoughts on that?
I will, but first I want to say something to Al, because since our preliminary discussion, I thought about this and I thought, who would be the trusted party who can make sure that my AI that's telling me how to invest my money or what medical intervention to get is actually working on behalf of me? Who is this God who can do this? And I think actually this combines with another technology which we're hearing much more about, which is what cryptocurrency is based on. And this is a distributed trust. So we really need to combine the AI with distributed trust networks. And then in that distributed trust, without there being a single master we can trust, we can do that in a distributed way. So that's just a comment to what Al said that I've been thinking about since our discussion. So we should put the cryptocurrency people together with the AI people and do this. Now, getting back to the question that I was just asked about ethical AI and fairness. If you just come up with an algorithm in which you say, okay, what I want to do is, for example, I want to decide who are the people I should interview for a job in a technology company, like Microsoft or aspects, parts of the Vin group. If I try to train my AI on the data I already have, it may, and even if I say don't use gender and don't use race, you're not allowed to use those. The algorithm will find proxies for those. It will find things that are correlated with gender and with race. And it might return to me scores for people who are just like the other people I've hired, the other good people I've hired. So when we do these AI algorithms, we have to be very, very careful to make sure that we write them, and I've actually personally worked on this, that we write them in such a way that they mitigate rather than exacerbate bias. And if we're not conscious of it, it will exacerbate the bias. The other thing that I think is very important here is that these algorithms are being used increasingly in platforms that control the distribution of resources. So, for example, in the US, the distribution of health resources, the distribution of educational resources or social welfare resources, or that make judgments like this AI might recommend to a loan officer who should get a loan, might recommend to a judge who should be offered bail. So these are very important, very consequential decisions. And again, if we're not careful, the AI can exacerbate the bias. For example, Obermeyer and Mullinaten a couple of years ago demonstrated that in the United States, two people with the same health insurance, a Black man and a white man, the Black man would be offered less good medical treatment because it would look at what was done in the past. And even though it wouldn't be allowed to use race, it would find proxies for race. So it's really, really important that we are aware that this can happen and that we write our algorithms explicitly to avoid these things.
Thank you, Jennifer. You know, humans are notoriously prejudiced and biased. And we've built societies with that. Does that mean that, in fact, AGI may not be such a good goal to achieve because we'll all build learning from humans may not always the best things in terms of behavior. How do you, because we rely so much on machine learning, which is based on how teachers teach. How do we deal with that?
So I think that we need to come up with algorithms. For example, a few years ago, a group of people, me and some wonderful interns and other researchers, came up with an algorithm that was actually less biased than human judgments in things like deciding who was going to be offered a job interview. So we can build our algorithms just like, although there are a lot of bad folks out in the world, we can raise our children to be aware of this. And people do this, right? They raise their children to model the ethical rather than the unethical behavior. And using various clustering techniques and other kinds of technical things, which I won't get into here, we actually made our algorithms fairer than the human judgments. So, but you just have to be aware of it. And this has to be something that you teach everyone as they are learning AI, that they have to be aware of this and that they have to make algorithms that compensate for this. So in Vin University, where you're going to be teaching people about AI, it's very important that the students are aware of the pitfalls and of how to remedy them.
So this is a slight digression. I'm going to ask Professor Wu. You're a theoretician, theoretical computer scientist. Are there objective ways of defining things like fairness so that we can let AI be measured by that success rather than being as good as humans in performance?
Yeah, that's the tough questions. I don't know how we can define fairness here because right now it looks like we just try and tell we need data or we need statistics from the algorithm to see how it performs first, right? And then we fix it. Because the way, deep learning work now actually, then sometimes it's very hard to predict that what happened at the end. So it's, in my point of view, it is somehow will be a very difficult task to start to design the algorithm from the very beginning and say that it have to achieve this thing at the end. But probably we have a better chance that maybe run it on some experiment and go back and fix it and so on. Yeah.
Just like we do. We make mistakes and keep fixing.
Yes.
Anandan, could I add a point to that? So I'd like to go back to this topic, but now from a different angle. We've seen courts develop jurisprudence in order to make laws better and better to govern societies, right? And we've seen laws originally introduced that didn't work quite the right way, and they get repaired. So what's missing, and I want to add more now to the fiduciary argument, what's missing is the right to challenge. Because in every court, even with AI systems that set bail, this is during a bail setting hearing. There is someone speaking on behalf of the accused, and there was someone speaking on behalf of the prosecutor. And so even in those situations, there is the ability to provide a challenge. So there may be some group trust system that works, but there needs to be something oriented specifically to the individual so that at the right time, in the right place, a challenge can be made. And when we look at the impossibility of getting data that's completely clear of prejudice, this is something that courts have been working on for centuries and centuries. So I don't see us taking enough of the machinery or the logic from those situations and applying it so that whatever AI we put together, and it's all based on the data and the algorithms, of course, you have a process by which it gets scrubbed, not a process by which you say, this is it. And there is no way for the ordinary person to make a challenge if the result is deleterious.
Thank you. I want to switch to...
I have something to add to this, which I learned about a year and a half ago, which is really surprising. In the United States, you can now be convicted of a capital offense. That means since we have the death penalty, you can be put on death row due to the output of proprietary software. So what does that mean? That means that the output of the software can be entered as evidence, and because it's proprietary, we do not have the right to challenge it. So we actually have two faculty members here, one a lawyer and one a computer scientist, trying to show that some of this software was used outside of its domain of validity. But these are the kinds of issues. Now, this is particular to the laws in the United States, but it's something that countries throughout the world are going to have to deal with. How do we maintain the fact that this is proprietary software so a company doesn't have to reveal its code, and yet it can be challenged? So these are difficult questions for which there are some technical and some normative and regulatory solutions.
Good. I mean, you're scaring us a bit, but I'm going to go back to what Professor Wu said. You know, we make mistakes and learn and correct them.
So I don't know, maybe if I can add, actually, I have a more optimistic view about this, right? So Anandan, you said that, people, we are also prone to bias and prejudice and so on. And right now, we actually have, a sub-community in AI, right? A lot of smart people thinking about fairness in algorithms. And fairness actually comes from not the data. I mean, the data is just the data, but fairness is a property of the decision-making algorithm, right? So basically, I don't think we have the answers yet, right? But there are ways you can think about this, right? How do you design algorithm that actually leads to decision that are unbiased, where it doesn't really matter which population you're looking at, right? So you can actually put in rules where your AI models have to conform to, right? It has to perform the same way for male population, same way for female population, for example, and therefore it is fair, for both male and female. So I think those are the topics that, once we humans think deeply enough about it, we can actually control it, right? And perhaps, that's kind of like a way to be more optimistic about this.
Yeah, I think
I wasn't meaning to not be optimistic, actually. I won an award for designing such an algorithm. I'm just saying that we have to be aware of it, that's all. And the students we teach have to be aware of it. This is going to become how we teach AI algorithms, that you need to put this in. It's very, very important. Like if you build a piece of equipment, it can't be faulty. There are tests that you have to run. And similarly, we'll do that here. I completely agree with you. No need for pessimism, just for awareness.
Yeah, no, got it. I think, as I said, as Professor, I think we learn, we are designing these systems. I think that's something to keep in mind, and we can certainly control the evolution of that design. Let me switch to another topic. The topic is kind of close to my heart, which is something came up yesterday, but it's, it bears repeating here, which is when I look at the usefulness and applications of AI, I see there is a sort of a divide. There are those of us who are normal life, in the normal socioeconomic life. We download apps, we go to the store and buy things, we have economic capacity, we are self-managing, and a lot of AI benefits will come to us, be it assistance, personal assistance, or managing your car driving, parking, whatever, or in healthcare benefits and stuff. But then there is about roughly half the population of the world, maybe a little less, who really are not part of that economic system. They depend a lot on help from government sectors and social sector. And in these places, technology, while it can be useful, their application may not be straightforward. In fact, to really address the needs of these poor communities would require going down to understanding what are the specific issues, which often tend to be somewhat different in the set of things. Moreover, in terms of actually getting it implemented and scaled, there's not a good commercial model because there's not a lot of money out there to pay. So you have to rely on working on with governments and government programs, and those can be complicated. And there's not enough incentives for tech innovators and companies to take that trouble. How do we actually bring the power of this technology where it might be actually needed? Because in many cases, the expertise, say for instance, medical decision making, and for poor people is actually not there because doctors are not serving poor communities, so they rely on very poorly trained doctors and medical help. Something like AI can actually help improve their capability, yet how do we get that technology? This is something that that I have been worrying about, but it requires a conscious effort on the part of the more have society to actually address it. I'm curious if any of my other panelists have some thoughts on this.
If nobody else does, then Anandan, first of all, I really want to praise the fact that Anandan, for many years ran a lab with a huge focus on this in India. So I think that a lot of advances came out of that lab, like a way of following up on TB that really lowered the TB rate in poorer countries, first in India, and then I think in some other countries. So really, really important work. I want to mention one other example. The UN and the World Bank were trying to distribute resources in Togo and Afghanistan and other places as COVID hit and people were just on the boundary of starvation. And yet it was hard to know who are the people who need the money. It's, when you're in a country like Togo or Afghanistan, you can't just look up people's tax records and say who's poor and I'm going to mail out a check to them. And so there were some researchers here who used satellite imagery and who used non-smartphone data to try to locate where the poorest people, the people who were just on the verge of starvation would be, and they distributed a lot of these resources based on that. So yes, there are cases where we can try to use AI and very limited information that we have to better distribute resources, or as Anandan says, to have substitutes for doctors or to help doctors who are not as trained. So I think there are there are cases in which this can be done, but there's the incentive problem, which he mentioned. This is not going to be driven by big tech. This needs to be driven by governments and philanthropists.
Yeah, and with some incentives to the big tech and come and play in the right places. Let me ask Al and then...
Yes, I have a thought I want to add. Let's talk about assisting doctors for just a half a second. I know that there's very valuable AI approaches, I think some of them right here in Vietnam, that assist doctors in diagnosing tuberculosis in lungs. And that, I would offer, is a very interesting scenario where the doctor would be very motivated to embrace such a system. To be reading X-ray after X-ray all day isn't using a human at their best capacity, right? You get tired, you get fatigued, you might miss something, and everyone knows they don't want to have a small spot ignored and then find out they have a big problem later. So I do think that aside from other motivations, there are other special motivations where the individual practitioner will have enhanced abilities and will be personally motivated. To go back to the idea of challenge and verification, since that person's a doctor and they see their own diagnosis rate improve, their accuracy improve, they themselves would be self-critiquing as they go. So I just wanted to add that in, that I think there are things that are already in progress and we could use as a basis to accelerate.
Yeah. Oh, thank you. I should mention there are quite a number of applications such as this. X-ray reading today in many cases are actually done better by AI than humans, actually, even trained radiologists, simply because the details that you have to see may not be visible to the human eye. But getting them implemented in the right settings is still a systemic challenge. Another one is distributing malaria nets in certain African countries. Currently, uses AI. We ourselves, in my past work, used to work on low birth weight baby weighing and monitoring, pest management in cotton. There are many applications, but my main point is that it takes a little bit beyond individual application to create a system loop that will help propagate this. XD, you had some thoughts?
Yeah. All of you said something amazing. I just want to add two really underprivileged groups that the AI can do a tremendous help. One is really there are 7,000 languages spoken on this planet today, and half of them will disappear. When language disappears, so goes the tradition, culture, and the community. So AI can really help to preserve world's language. That's one. Number two is really, if you cannot see anything, your life is going to be hard. So we worked to provide a free app called the Seeing AI to help those vision impaired people rely on cognitive services. So you basically point to your iPhone or anything, they will tell you what is going on, how much money it is if you're running into someone else. So this is really some real example that everyone can use today, whether you are using translation software or the Seeing AI app. With the vision, you can really just basically tell people what is going on around them. So those are two underserved communities that Microsoft is working hard to help. But that's not enough. We support only about 120 languages, far away from 7,000 languages that are waiting for us to really help.
Thank you. I want to actually, I'm realizing that we are probably progressing more slowly than we had planned. So let me switch topics around again. Of course, we are in Vietnam, and there is WinAI, and there must be a lot of excitement about AI in Vietnam. So I want to go to that topic next. Hung and Professor Wu, you're both here. You've been building AI. Can you share with us what your aspirations are, how you see the future of AI playing out in Vietnam?
Okay, so maybe I can start first. So WinAI started about 3 years ago, and when I looked at it, and there is already an equilibrium, right, in Vietnam in terms of the business needs, in terms of the current state of technology, in terms of the current state of training in education and research in AI. Now, obviously, I want to kind of like break that equilibrium and move it to a state where it is actually has better outcome, quality, and so on. So one of the things that I decided to do is, because I can't do too many things, right? So in order to break this equilibrium, what I attempted to do is to pick on one aspect of it, and that's focusing on research and science, right? So in a sense, WinAI at the start was an experiment, right? So the thesis is that can we actually build a world-class AI research lab, but do that right here in Vietnam, in a developing country, right? Honestly, at the start, I wasn't even sure myself whether this experiment, how it's going to pan out, because as you all know, AI is dominated by the likes of, Google, Facebook, Microsoft, and so on, right? Big companies, especially in Silicon Valley. I think 3 years later, now, I think we can safely say that WinAI is now an established world-class AI research lab. And we regularly actually benchmark ourselves against all the other top research labs according to the exactly criteria that they're using in terms of the number of publications in really the top-notch conferences in AI, which is the one that's really matter. This year alone, we have 8 publications accepted at NeurIPS, which is the #1 conference in AI, and that's absolutely was unheard of in Vietnam before. So I think, at the moment, my sense is that I managed to break that equilibrium somehow, right? And I hope that now that the other parts going to move together with it, right? So we also need to address the problem of training, education, how we're going to be able to generate the talents from the local population, which, with our AI residency program, we also found out that there are really, really many young, talented people who's working very hard in Vietnam and is really capable in contributing to top and world-class research. But then it's also, part of the equilibrium is the business side, right? What are the applications? And I'm sure that there are so many applications, not only in Vietnam, but also in the global market that you could actually use to drive this technology and create a sort of like a sustainable equilibrium. And it's also the role of the government and so on, right? So yeah, I think that's kind of like, where we are today. And I'm not sure whether Professor Vu would want to add to that.
Yeah, thank you. So I am heading another unit, which is called Win Big Data, which we started about the same time as Hung's unit. And so when I started it, my vision was a little bit different, that I wanted to really bring AI to Vietnam as an useful tool for the people, that we can really benefit from it. And the way I see it, if we want to build AI system, then there are 2 things we need. First is clean data set, which everybody know. And second is a pool of very talented people who are willing to work on it. And fortunately for us, although Vietnam is still a developing country, we have abundance of these 2 items. So actually I found out in Vietnam it's easier to collect data and clean them and label them than in many other countries. And also the Vietnamese young people are very well educated in mathematics, so they have a good background to go into machine learning and things like that. And then that is 2 things. Built on these 2 pillars, we try to build up actually a real product especially product in natural language processing, which is actually based on our own, language data set, which is our power here. And after 3 years, actually, we managed to do quite a few things. For instance, we all heard about VinFast, which is the car that have been on the news in the last month or so in both Vietnam and in the US. And so on that car, we have many voice assistant systems in English, in German, and so on. And there's one in Vietnamese called VV. So it's 2V in there because our company is after the V letters. And that is the voice assistant that we built at Vin Big Data. And I'm very proud that is the one that knows the most jokes among all the voice assistant on the car. And people really enjoy it. So I think in Vietnam, there is, with this trend and the enthusiasm among the young people, with some vision, we can actually lead people into building valuable products for the mass, for the public. And that is something that we try to do.
I know in the past conversation, Hung, you mentioned you wanted Vietnam not to be only a consumer of AI, but a producer of AI. And from past experience, the best way to do that is to just have lots and lots and lots of AI scientists coming out of here and startups and companies. How do you see that vision shaping? Of course, Vin's example is stunning. Everything they touch, they seem to do it in lightning speed, more than rocket speed. And I'm curious where you're going with that.
Yeah, so actually this is the energy of the people, also the quality of the talents here are, I think, two of the outstanding things that we have in Vietnam. And with the development of the economy in general, you're actually seeing opportunities for new startups, opportunities for young people to really take part of this technology and be a part of it and reap the benefits. So I would say that at this moment in time, we're looking at a really bright future in order to create that future where the people in Vietnam, it's part of the game, it's part of the producers of the AI products and technologies, and not only the consumers. So, basically, I think science and technology in Vietnam is also viewed as, by many, many people actually, across the population, including parents and so on, which are the people who really matter, right? They actually want their kids to do really well in their education. So science and technology is often viewed as the hope and the aspiration for the country, the next generation, and so on, right? So, I'm very optimistic on that.
I'm actually not sure how much the clock is saying we have, and also how to read the clock, but we do have a couple of topics. One, I want to maybe spend a brief amount of time, and really because I find often audience don't really understand how much AI has been already influencing the progress of science research itself. And I know Jennifer and Professor Wu, you both have been thinking about this. So it'd be worthwhile just sharing some thoughts on, what's going on, how is science benefiting from AI already, and where do you see that?
Yes, so I think there are two sides of the coin, right? So the one thing is that AI benefit other areas of science like medicine that Jennifer already mentioned. So, beside the obvious application of AI, like we know language processing or computer vision, actually now we use AI in many other areas that we didn't think of before. So I have heard experiments in drug discovery. Like this is one very simple example here that I can explain. Like making drug is a long and very expensive, process. It can take like 10 years or something. But then people realize that, yeah, and in that process, the expensive part is to test the drug to be safe, right, for people. So it's not only cure the disease, but doesn't make any, side effect. And now it turns out that there's a brilliant idea here is that one drug actually can cure many diseases. It can cure other diseases that we do not design the drug for, but we didn't know of it. And then with AI technology and big data, tools right now, actually, it is the whole direction moving, saying that, okay, we look at existing drugs and see that maybe they can cure something else other than the purpose of it. And that is something I think it can be hugely beneficial for people because, we save so much energy and money. So that's the one part of the picture that techniques from AI can impact other area of sciences. On the other hand, it's also inspire other area to investigate AI. So you can compare it to the time when Newton made his discovery, right? So physics was on the rise. And then it impact other sciences like mathematics. Right? People develop mathematics to understand physics. That's what Newton did. And now AI have a similar role in science. Now it motivates other science to invest in it. Like mathematics, suddenly we have many other branches just to understanding what AI is doing. And so that's another kind of impact on science.
Jennifer, do you?
Sure. So I want to just mention a couple of other examples. There were for 25 years, people were trying to figure out how proteins fold. It's very, very important for drug design and many other things. And AI is very good at looking through large spaces that are much too large for us to do in any other method, and looking for latent features that are really important. So AlphaFold is this absolute breakthrough in protein folding, which is using the same techniques, very cleverly done, but using many of the same techniques in deep learning that people had seen in other contexts. Also, there are other cases where in the physical sciences, people haven't known what to do. Either there's too little data, for example, in astrophysics and astrophysical models, and what's happening is that the machine learning is suggesting surrogate models. So these are models that are different, that are not the equations of motion that people started with. Also, there are cases very important for problems we all really care about, like climate, where the equations of motion that predict climate, the physics equations, are too complicated to run even on the largest computers in the world. But these surrogate models allow us to do that. So I think there are many, many advances that we are seeing in other domains that will have implications for health and climate, but that are going through very basic science that are being impacted. And then, as Vaughn said, Vaughn and I are both mathematicians by training. And he was actually an intern in our group at Microsoft 25 years ago or so, Professor Von Vu. So both of us also really love the mathematical question of why is this working, and bringing mathematics to bear on why certain techniques in deep learning are so successful. So yes, I agree with him. There are two sides of this coin.
Thank you. So we have just about a minute. So what I want to do is to ask for each of the panelists to make one closing statement, preferably, but you don't have to, about the future of AI, where you see AI going in the next 20, 50, 100 years. I know I'm putting you on the spot, so I'll start. So give each of you a little bit of time, and then I'll call on Al and Hung and XD and Jennifer and Van. I'm an optimist. I think it's a technology that will help us discover more things, connect people in a way that we have not been able to, reduce tedium in various everyday life routines, increase safety. But I think it's going to be something we have to manage carefully in order to deliver those results. I don't believe that it will go out of control, because I think we know how to manage and control our technologies. Al?
Great. Just very briefly, I agree with what you say, and I just want to add that I think the future will also include a way for the individuals to challenge and have an understanding of what's going on.
Huh?
So I think with what we've looked at today, especially other people have said on the panels, I hope that people here online or all the other people who are interested in this can actually see that AI has an enormous opportunity. It's actually will have enormous impact in our life in the years to come. And with that, with the kind of disruption that it brings, it also brings opportunities. I hope that you can actually convey the aspiration to you, to the people who are working in this field or will be working in this field, especially in Vietnam, in other developing countries, that this is actually an opportunity for you to be part of it and to really make the most of it. And what you really need is just to believe in yourself, and you will have people who can actually help you and work with you along the way.
XD.
Well, I think AI is going to fundamentally transform the society, just like the last industrial revolution. It's a new tool. It's a new tool to amplify the creativity, communication, everything we do.
Jennifer?
So yes, I see AI, as XD was saying, as a partner to human beings, to make us able to do more and to provide opportunities for people. And in the future, I plan to go to Vietnam for conferences in AI as Vietnam becomes one of the leaders in AI.
And Professor Wu.
Okay, so I would agree with everybody that the future of AI is bright and its potential is enormous. But we also have to take care of the public awareness and education, because without those, I think AI may go to a wrong direction.
Thank you.
Thank you, Dr. Anandan, for facilitating this panel discussion, as well as thank you, panelists. We will now open the floor to Q&A, but before we proceed on to Q&A, I have received information from the Minister of Information and Communication. He extends his welcome and his strong interest in our event today, even though he cannot be here physically, so he extends his interest and welcome to everybody. All right, so on to Q&A. We will, again, have both offline and online Q&A. And for the offline Q&A, I think we will do it a little bit differently for panel number 2. We will start with the online questions first. So we have the online questions right here with me. And just a reminder, we do get a lot of questions. Not all questions will be answered today, but the show, and we all encourage everybody to continue these discussions even after the event is over. So the first question is from Mr. Javier Ibanez Guzman. And he is from Autonomous Systems Expert, Renault SA. His question is, AI-based solutions for critical safety applications, how to make them trustworthy? So panelists, would you like to address the question?
Who wants to take it? Jennifer?
It's funny. There's a question of what are we going to ask of things like self-driving cars? Are we going to ask that they be perfect in some way, that they be much better than human beings? Or are we going to ask that they be at least as good as human beings? So in the general question of trust, the first question is, wouldn't it be good enough if we cut the death rate incredibly by using self-driving cars? In terms of trust trust and security, this is a huge area, and we do have to make sure that as we use these kinds of technologies, no one can get in there and cause an accident or something. So we are always in any area of technology, we're always making it safer. We see what doesn't work in the security, and it's a kind of ongoing battle, but I think one that we do pretty well.
Thank you.
All right, thank you. We do have a second question from Professor Cheung Jung Dun, Oslo University, and Northern Taurus Artificial Intelligence, AS. His question is, having good data is a crucial part of having good AI models. What are some good resources to get labeled data to train deep neural networks and provide easy access for startups or small teams with reasonable costs? What's your take on this?
So either XD or Hung, both of you have built systems.
I'm happy to really give you a practical answer. Microsoft Cognitive Services offer probably the most comprehensive AI services. So whether it's a speech recognition, computer vision, facial recognition, translation, anything you can name, or even the GPT-3 is part of cognitive services that's offering from OpenAI. So my suggestion is do not start from scratch. Take the models, then customize. When you customize fine-tuning, if you take a GPT-3 fine-tuning, you need only a small amount of data. So computer vision is very similar. We actually created a new breakthrough just last month with one unified model representation for computer vision. It's called Florence. It's actually published. We reached the 40 plus state of the art on the open benchmark. 40 different research benchmark. Is one model reached 40 SOTAs. So then you fine tune. Practically, you don't need to really spend a lot of money. That's my practical solution.
Thank you. Hung, any answer from Vietnam perspective?
Yeah, sure. So if I can add to that. So actually at WinAI, we're actually working on solutions in order to build AI system that requires, number one, less data, and number two, less annotation in supervision. So we believe that this system is going to bring down the cost of creating and building other AI system, which is going to help to democratize the technology and bring it to this part of the world. Specifically when you talk about annotation, then one way you can actually make it cheaper and more efficient is to actually apply AI to the process of helping the annotators, right? So you can look at techniques like self-supervision, you can look at techniques like auto-labeling, which would drastically bring down the cost of annotation itself. And then you can also look at problems whether you really need to annotate all of your data set or not, all of your part of it, right? And these are really getting into really cool and fascinating topics in machine learning, where you talk about active learning, where you talk about how to decide which of your data is most valuable to annotate, which is going to bring further cost down in terms of how you're going to be able to develop your tools and your AI models. So yeah, I mean, these are really fascinating research topics and lots of application in machine learning that we're working on.
Yeah, thank you both. Next.
All right, to our audience offline, it's now time for you to ask questions. I see a couple of questions there. I see a hand over here and a hand over there. Can we have the mic for our audiences, please? Yes, so microphone, can you first go to our gentleman over there, please? Would you kindly introduce your name and ask your question? Thank you very much.
Yes. So my name is Nam. I'm from VNG Corporation from Ho Chi Minh City. and where we actually will also developing some AI application to enable more accessible services to everyone, like in banking, financial, and learning. However, one thing we observe that the more we bring AI to practical application, the more we see that we need to localize those AI technologies to the market. And I was wondering, like, what do you think about it? Like, do you want to focus on general AI problems, solving general AI problem, or do you need to focus more on localizing those technology to make it more practical to a particular market?
Let me take a shot and then maybe one of the others. I'm a believer that you start with particulars and then get to the general from there. And I think we are at that stage still. But as we abstract a common set of problems, something more general may emerge from that. But do you have?
I can add a little bit color. So once again, do not start from scratch. There are a lot of open source models available, and Hugging Face is good source. GitHub, just there are tons of open source solutions. So start from there. If you don't want just, if you can, consume cognitive services or Google or Amazon AI services, that's also a good starting point. Like when we introduce the cognitive services, the biggest lesson I really want to differentiate, not everyone is aware of that, is we understand that AI, general AI, will not be good enough for everyone. So we always introduce custom speech, custom vision, custom translate, custom language. So we let the developer to take a small amount of data to customize the pre-built model for their own application. That goes a long way. Even GPT-3 with such a big model from OpenAI, if you don't fine-tune, if you don't customize, it's not that useful. So there's no such a solution. It's AGI. You can just actually do everything. It doesn't exist. Even with the great trained state-of-the-art speech, vision, or language model, you need to customize to get the best outcome. Not the last mile is very important.
Yeah. Thank you, XD.
I'd like to say something to this also. I think it depends on the scale of your company. Okay, so if you are, if your company is not of too large a scale, then you really have to just be thinking about customizing to your particular customer. If you are a Microsoft or a Google or a Vin group, then perhaps you can afford to have a general research group in AI or a general research group in data science that is looking at more general questions like, how do I improve active learning or self-supervision, as Hung was talking about. But I think, in the end, the rubber meets the road when you have a particular problem. And if you are a company that's looking at enough particular problems, then you might want to step back and have research groups that are looking at those questions going across problems.
Thank you, Jennifer.
Wonderful. Thank you, panelists. I think we have room for one more question. I think there's a gentleman over here with a question. Can we give the mic to the gentleman over here, please? And we will have the third question as well, yes.
Fantastic talk. Thank you very much. So I'm Viet from Stanford University, and I'm very glad today that we talk about ethical AI, and I actually want to mention about equitable AI. So Vietnam is not the first mover in AI, and apparently there's a huge gap between Vietnam and other countries. So that includes the US, Europe, and China. So many of these gaps are because of historical reasons. So from the policy viewpoint, what can Vietnam do in order to close this gap? And from the international viewpoint, what can Microsoft and also the UC system may help for us to close this gap? And closing this gap is not just for Vietnam, but also for other developed countries. Thank you.
There are multiple questions there, and now in the interest of time, I'm going to ask Professor Van Wu to take the questions that are specifically related to Vietnam, perhaps, and answer that.
So relate to Vietnam, I think the gap you are talking about actually exists in many other areas, not only AI. I think the first thing we need to do is to raise the awareness, the public awareness of science in general, and then increase the amount of funding, and also make the policy for funding so that young scientists can work on daring projects like push the science forward. And that is first thing we have to do. And I think with the help from outside, I just mentioned the UC system with 2 professors here. I think if we can establish like strong research group and centers, then probably we can get help from outside, that people will come and work with us and bring the technology with us. And now I think in this age, the good thing about AI is actually the research is very open. People do not keep too much secret, like secret formula of Coca-Cola, things like that do not exist anymore. Like if you do something, then in a few years, you want everybody to know about it. And then if we have strong research system ourselves, then it's very easy to bring any top scientists to come to Vietnam and work with us. And all these things together may probably push us forward and reach the level of the countries that you just mentioned.
Okay, so we're almost out of time. Maybe the one last question.
All right. So I think there are 2 hands raised really high. I think let's start with this gentleman, and then we'll go on to that gentleman for both questions asked together. How about that? So can I have the mic?
So maybe we could have a question from a female audience. So far, we haven't had one.
All right. So can I have the mic, please? Due to Dr. Anandan's request, there's a female in red over in the corner. Yep, the mic is coming to you right now. And
hello, hi. Hi, my name is Kim. I'm from Vietnam National Television. I have a question for all the panelists here. How important is it to apply artificial intelligences in fighting against COVID-19? And can you please elaborate some examples that many countries in the world have used? Thank you.
Anybody has thoughts on this? Yeah.
So I think that, we have been helping organizations throughout the world fighting COVID-19. Teams is actually a good example. We use Teams all the time. On Teams, there are a lot of AI-enabled technology. Even on the organization, for the Italian post office, because Italy was in crisis in the early stage of COVID. So we offered a telephone number for people to get information from home. So it's easy to reach everything, right? And for the US, the AP test, and we enabled the AP test for students to take that from home. And because of the OCR recognition, we are able to really process all the, tests remotely, digitally. And for the UK's National Health Services, we enabled them to have face recognition to identify the patient. So whether it's in the UK, Italy, or US, we helped across different organizations use AI to make their life better to fight COVID.
Yeah, I should add.
That's just a few examples I'm very familiar with.
Thank you. Also, back when I was in India 2 years ago, when the whole thing started, we worked with the Mumbai city government to do some epidemiological modeling to predict resource burdens on hospitals and nurses and so on. And there are a number of parameters in those models which we ended up using machine learning to learn to set the parameters. So, last one. Are we done?
Do we have time for one more question? Yes, sir. Yes, sir.
This is the last one.
Yes. And then for all the other remaining questions, there will still be opportunities for you to ask them, after the panel has finished, and we will have time for people to mingle.
I think he needs a different mic.
So my name is Stephen Trương Quốc Hùng in Vietnamese. I'm the Vinh Brain guy. And first, I'd like to introduce, congratulations the panel. You are powerful because power AI created by human. You are on people. You are human. And AI cannot replace empathy. You have it. So I have one comment and then one question for us to think about. So the comment is about, ethical and fairness. So I think that besides, Din Ao mentioned about the challenger, the validation, I believe that, a system that design of awareness that Professor Jennifer talking about is relinquished to, one of the systems that used to be a chatbot that answering. And when the data got teaching, do you like Hitler? If someone try to answer and keep teaching the system, say, I do like Hitler, and you keep doing that, you have a lot of data. And the chatbot may answer and say, yes, I do like Hitler when someone asks that. It gets into an ethical issue. So as a practitioner, and also how to be awareness of design the system to prevent that, we always build in, beside the model and the training the data, we build in a memorized system that allow to do whitelist and blacklist. So if you today, you have a blacklist that say, if someone asks, do you like Hitler? You will say no, and then you will respond to that. So that's one of the ways that I believe as a practitioner, you design a system to prevent this kind of thing happen. It's a memorized system that you can correct and help allow human to make the adjustment right away when the model got trained in the correct way. Okay, so the question, the second part is talking about the question. So the question today is, as my company doing AI for healthcare in Vietnam, we go across of the thing that XD, Dr. Siddham Wong talk about the modality, across modality is a big challenges of AI in the future. It's illustrate into my own world of you have a different kind of modality like X-ray on the way to CT, and also across the boundary of computer vision from the medical imaging on the way to medical report. That need to bring both the technology of computer vision and the LP together. So this lead a way for us to think about not just only from the data modality, it's also technology in the way to solve the problem. And that's also bring up to the space problem. What if we think about the historical, which is the time space in here, where you have a detected cancer, but if you cross back to the history of the patient, which is personalized data, you find out that 2 years ago, that patient have the X-ray with a nodule, which is a mass. It can tell the progression of the cancer, which is very helpful for the doctor to solve it. So that is the question for us, is to not only from the modality, cross-space, technology across, but also from the time-space perspective. Thank you.
Thank you. It was much more a closing comment than a question, but let me ask, as the one of the leading AI experts in Vietnam, Hung, to maybe use that as to make a quick closing remark with that question.
Okay, so I think since the event is in Vietnam, there's so many people in the audience today in Vietnamese. Perhaps I want to switch to Vietnamese in what I'm about to say next, and perhaps, someone can actually help me to translate it back to English. Sau cái phiên họp panel ngày hôm nay về tương lai của AI, khi mà chúng ta đã nghe được rất nhiều những cái đóng góp rất có giá trị, những cái câu hỏi cũng rất là hay và cũng có rất nhiều giá trị từ tất cả mọi người ở đây, thì tôi thực sự hy vọng là Vin Future Prize có thể truyền tải đến các bạn, những người đang làm việc trong cái lĩnh vực về Science and Technology và đặc biệt là AI, cũng như là những người sắp muốn trở thành những cái chuyên gia trong cái lĩnh vực này. Tôi hy vọng là chúng tôi có thể truyền tải cho các bạn một thông điệp là AI thực sự là một trong những cái mũi nhọn của học công nghệ hiện tại, và nó có thể mang lại rất nhiều cái thay đổi cho thế giới trong tương lai, và nó thực sự là một cơ hội, và các bạn hoàn toàn có thể nắm lấy nó. Các bạn chỉ cần vững tin vào bản thân mình, vững tin vào những gì các bạn đang làm. Các bạn chỉ cần có lòng tin vào chính mình và đặt cái mục tiêu cao hơn một chút, và tôi tin là các bạn sẽ có những cái sự đồng hành từ những cái tập thể, ví dụ như là những cơ sở nghiên cứu như VinAI, cũng như là cái network của rất nhiều những cái bạn bè trên thế giới như là các bạn nhìn thấy ngày hôm nay. Xin cảm ơn.
All right, thank you very, very much, panelists, for all of your answers. Dr. Anandan, thank you. Thank you, Dr. Bui. Thank you, Professor Vu, Professor Pisano, as well as Professor Chase, Dr. Huang, for joining us via Zoom. Thank you very much.
Thank you very much for all of us.
Now, ladies and gentlemen, to remind you, the Vin Future Prize honors science and technology advancements that service humanity. And a very fundamental part of our humanity is also lunchtime. So it's now lunchtime. So kindly proceed to the Princess Ballroom for lunch. We will commence with the third panel at 2 p.m. So if you can be back here by 1:50, that'll be wonderful. So enjoy your lunch at the Princess Ballroom. Thank you very much.